Welcome to the viewers. Now we discuss Liouville's theorems. At first we are discussing the statement of the theorem. Let's take watch. If a function gz is analytic for all finite values of z and is bounded, then gz is constant. At first, which conditions we have? This is analytic for all finite values of z and it is bounded function. Then we have to prove it is a constant. Now part of proof. Let z1 z2 be any 2 points in z plane. Now choosing the contour C to be large circle of radius R, centered at origin and containing the points z1 and z2. Therefore, mod of z1 must be less than r and mod of z2 which is also less than r. This is our criteria. Also, as gz is bounded, therefore there exists a positive constant capital M such that mod of gz is less than equals to m for all z using these conditions. Therefore, by Cauchy's integral formula, we have g of z1 is equal to 1 by twice pi I integral over c gz dz by z minus z1 and g of z2 is equal to 1 by twice pi I integral over c gz dz by z minus z2. We are using these two states, and therefore g of z1 minus g of z2, that is 1 by twice pi I integral over c gz dz by z minus z1 minus 1 by twice pi I integral over c gz dz by z minus z2, and therefore 1 by twice pi I integral over c. It is after calculations, z will be cancelled here. So z1 minus z2 divided by z minus z1 into z minus z2 gz dz, and therefore mod of g of z1 minus g of z2, that will be mod of 1 by twice pi I integral over c z1 minus z2 by z minus z1 minus z minus z2 gz dz, and finally it will be less than 1 by twice pi I, and these two terms using here integral over c mod of z minus z1 minus z2 by mod of gz into mod of dz divided by mod of z minus z1 into mod of z minus z2, that will be less than 1 by twice pi I, and certainly it will be z1 minus z2, and gz will be less than m integral over c mod of dz by and we using the conditions here, that is mod of z minus z1, certainly it will be greater than mod of z minus z1, so it will be less than 1 by minus mod of mod minus z1 into mod z minus mod of z2. In this way we are using this result. These two will be subtracted here because we know this property, that will be greater than minus mod of z minus z1 in this way. So it will be 1 by reciprocal, so that will be less than, and that will be equals to 1 by twice pi I, and it is using this condition that m we used as we use mod of gz, that will be less than equals to m. Already we using this conditions 1 by twice pi into mod of z minus z1 minus z2 into m divided by, and that will be less than r. So since z1 is less than r, so it will be, if minus is absorbed totally from these two terms, so it will be mod z minus equals to mod z minus we are using here r minus mod of z1 into r minus mod of z2, as we use, because we are considering the circle mod z equals to r in this manner, and outside the integration over c dz, and it is also mod of dz, and again we use mod z equals to r if we take, which implies z equals to r e to the power I theta, if we taking the conditions, and better to say, let us consider for r e to z equals to r e to the power I theta, then mod z equals to this, so dz equals to r I e to the power I theta, just simply calculated here. So mod of dz, certainly it will be r mod I1 and this also 1, and the result will be 0 to twice pi, because C is the closed contour, so the curve is already considered as 0 to twice pi. We using this result. Let's see. That will be equals to 1 by twice pi mod of z1 minus z2 into m, and if we take r common, that is r square, 1 minus mod of z1 by r into 1 minus mod of z2 by r, and if we consider as r will be outside of the circle, so mr, and result will be 0 to twice pi d theta, and using here twice pi will be the result, so 1 by 2 pi mod of z1 minus z2 into mr divided by r square, 1 minus mod z1 by r1 into 1 minus mod z2 by r into twice pi. So twice pi will be cancelled and r also cancelled, so mod of z minus z1 into m by r into 1 minus mod of z1 by r into 1 minus mod of z2 by r, and which will tends to 0 as r tends to infinity. That is very, very large radius, and therefore we can say that mod of gz1 minus gz2, that is 0, that is gz1 minus gz2 equals to 0, that is gz1 is equal to gz2, and as z1 and z2 are arbitrary, it shows, but it follows gz is constant. It is the indications, because all functions are same, arbitrary value. That's why these things happen. So in this way we end our discussions today. If you like this video, like it, share it, don't forget to subscribe the channel, and always press the bell icon to get all notifications of my videos. Keep watching. Thanks.